So this question was asked in GATE 2012. Consider a source computer transmitting a file of size 10 to the power 6 bits to a destination computer D. Okay. Over a network of 2 routers and 3 links. L1 connects S to R1, L2 connects R1 to R2, and L3 connect R2 to D. Let each link be a length of 100 km. Assume signals travel over each link at the speed of 10 to the power 8 meter per second. Assume that the link bandwidth on each link is 1 Mbps. Let the file be broken down into 1000 packets, each of size 1000 bits. Find the total sum of transmission and propagation delay in transmitting the file from S to D. Hey guys, I'm Pratik. Let's see how we can solve this one. So let's note down what is given in the question first. So file size is given, which is 10 to the power 6 bit, and that file is divided into 1000 packets, which is given in the question, and the packet size is 1000 bits. Means each packet is of size 1000 bits, and that complete file is of 10 to the power 6 bits, which is divided into 1000 packets. Okay, so that much information we have. So suppose this is a source which is connected to router 1, and then router 1 is connected to router 2, and then router 2 is connected to destination. Okay, so sender or S is connected to router 1 through link 1, and then router 1 is connected to router 2 through link 2, and then router 2 is connected to destination through link 3. Okay, and then the distance between the each link is given, which is 100 km, and then velocity is also given, or the signal speed we can say is given, which is 10 to the power 8 meter per second, and the bandwidth between each link is 10 to the power 6 bit per second, or 1 Mbps. Okay, so we know all this stuff which is given in the question. Now we have to find out the propagation delay. So we know about the propagation delay, which is equals to distance by velocity. So distance equals to 100 km, which is, we can say that 100 into 10 to the power 3 meter upon 10 to the power 8 meter per second. So when we solve this, we will get 1 millisecond. So propagation delay is 1 millisecond. And then now we have to find out the transmission delay. So transmission delay equals to L by B, and L equals to frame size, which is given, which is 1000 bits. Okay, because each packet is equals to 1000 bits. So 1000 bits upon bandwidth, and bandwidth is 1 Mbps, which is equals to 10 to the power 6 bits per second. And again, when we solve this, we will get 1 millisecond. Okay, so now we have to transmit 1000 packets from sender to destination. So suppose we are transmitting the first packet onto an outgoing link. So for transmitting the first packet, it will gonna take 1 millisecond, as the transmission time is 1 millisecond. And then to reach the packet from sender to router 1, it will gonna take 1 millisecond again, because the propagation delay is 1 millisecond. So in total, when the first packet reaches to router 1, it will completely gonna take 2 milliseconds, because 1 millisecond for transmission and the 1 millisecond for the propagation. Okay, so the first packet will reach to router 1 after 2 milliseconds, and while this being packet is transmitting, the other packets or the remaining packets are also being transmitted onto a outgoing link. Means the remaining packets are just following the first packet. Okay, it's like they are in the queue. We can consider like that the remaining packets are also in the queue, and when the first packet is on its way to router 1, other packets are following the first packet. I hope you got that. Okay, so it's like when first packet is transmitting, or when the first packet is on its way to router 1, remaining packets are also following the first packet. Okay, means they are also being transmitted onto an outgoing link. So first packet is at the router 1 after 2 milliseconds. Okay, So that first packet, after reaching to router 1, that packet is again transmitted onto an outgoing link, and for that it will gonna take 1 millisecond, and to reach that packet from router 1 to router 2, it will again gonna take 1 millisecond. Okay, so in total, when that packet reaches from router 1 to router 2, it will again gonna take 2 milliseconds. Okay, and as I told you, when these packets are being transmitted, or when this packet is on the way to router 2, other packets are following the first packet. Okay, means these all packets are in the queue. Only the first packet is taking 2 milliseconds, and the remaining packets are coming like 1 packet per millisecond. Okay, because they are already in the queue and they're already being transmitted, so they're following the first packet. So remaining packets are coming directly 1 packet per millisecond. Similarly, at router 2, the packet is transmitted from router 2. So for transmission, it will gonna take 1 millisecond, and again that packet reaches to destination. For reaching that packet from router 2 to destination, it will again gonna take 1 millisecond. It means that in total it will gonna take 2 milliseconds, and remaining packets are in the queue and they are following the first packet. Okay, so when we calculate this, the first packet will take 2 milliseconds from sender to router 1, and then again it is taking 2 milliseconds from router 1 to router 2, and then from router 2 to destination it is again taking 2 milliseconds. Okay, so it means that the first packet is taking total 6 milliseconds to reach from sender to destination, and then there are 999 remaining packets, and which are following the first packet, means they are just coming one after another. As soon as the first packet reaches to destination and the first packet is taking 6 milliseconds, all the remaining packets are in the queue and they are following the first packet. So the remaining packets will gonna take only 1 millisecond for each packet. Okay, first packet is taking the 6 millisecond, but the remaining packets which are following the first packet, they are coming like one after another, means they are just taking 1 millisecond per packet. Okay, I hope you are getting my point, and if you are not getting that, then you must have to learn sliding window protocol first. Okay, so as remaining packets are taking 1 millisecond each, so when we calculate this, we will get 999 into 1 milliseconds. So the remaining packets will gonna take 999 milliseconds to reach to the destination. Okay, so when we calculate total time, it will gonna take 6 milliseconds for the first packet, and remaining packets are taking 999 milliseconds. So in total they are taking 1005 milliseconds. Okay, so the correct answer is 1005 milliseconds.